All right, good morning, guys. So today we're going to do something a little bit different. We're going to look at what we call square roots, which should be something that you guys are familiar with from, I don't know, maybe 6th grade, maybe 7th grade, but if not, it's an easy enough topic. We should be able to pick up on it pretty quickly. So let's do something, a little review of something we've done a while ago, and let's see how much we remember. So we don't need to do number 2. But let's look at number 1. The length of a rectangle is 10 less than 5 times the width. The perimeter is 64. So I'll draw my little rectangle here. And we're, of course, going to call the width x. And it says the length is 10 less than 5 times the width. So this is 5 times the width, and this is 10 less. So the perimeter, right, the sum of all 4 of these expressions is 64. Now what happens when I add these expressions? Well, I have x plus 5x plus x plus 5x gives me 12x. And negative 10 plus negative 10 is negative 20. And that's equal to 64. So that should be easy enough to solve. All right, I get 12x equals 84. I'll divide both sides by 12, giving me x is 7. So now we have to go back. Well, what's 5x minus 10? Well, it's 5 times 7 minus 10. Which is 35 minus 10, which is 25. So my dimensions should be, if x is 7, 5x is 25. So if I add up 25 plus 7 plus 25 plus 7, it gives me 64. So let's answer the question. What are the dimensions? It's going to be 7 centimeters by 25 centimeters. All right, so let's talk square roots. Okay, so what's our textbook definition that we'll put in our notes? The square root of a number n is a number m which when multiplied by itself equals n. So for a lot of us that means nothing, right? What does that mean? Well, so if we take a number like 25, right, the square root, and then where the square root came from is if we said if we had a square with an area of 25, right, what's the side length? So if we take a square, and we say the area of this square is 25, there's 25 units in there, what's the side length? Well, the side length times the other side length has to give me 25. So obviously, 5 times 5 gives us 25. So that's our square root. Okay, so the square root of a number is the number you'd have to multiply by itself to give us that number. So the square root of 25 is 5 because, right, 5 times 5 equals 25. Now, if I was doing this in class, the next question would be, what's the other square root? And people look at me and they're like, someone says 0, and I say, no. What other number times itself? And someone says 25, and they say, well, no, 25 times 25 is 625, not 25. And I say, think about signs, and then someone says, oh. They say, well, what about negative 5? And I say, absolutely. Right? Negative 5 times negative 5 is also 25. So when we learn square roots in the 5th, 6th, 7th grade, whenever you learn them for the first time, we're just concerned with the positive roots because you haven't really got into negative numbers. Now that we're seeing negative numbers almost as much as we're seeing positive numbers, we need to understand that really every square root, unless specified, which we'll see, has 2 square roots, every number. It could be positive or it could be negative. So the symbol we use is this. It's called plus minus, and it's important that we use that symbol for all of these unless there's a sign next to the radical. So just to give you another example, and we may see this one in a little bit, right? If somebody says, what's the square root of 100? I'm going to say, well, the square root of 100 could be 10, because 10 times 10, or 10 squared, right? That's another reason we call it a square root, or why we call it squaring, is 100, but also negative 10 times negative 10 is 100. So I don't want to have to say 10 or negative 10. I mean, I guess I could. We're going to say plus or minus 10. And what that means is, could be positive 10, it could also be negative 10. That's a mathematical symbol that we use to represent the fact that something could be positive or negative. So let's look at 81, right? And I'm going to encourage you guys not to use a calculator. Yes, I know I just told you a couple weeks ago we can use it for everything, and you can. But if you're just putting this into the calculator, you're not really practicing understanding of the square root. Yeah, we'll have a calculator for everything that we do going forward. right? But if somebody is asking you something about, like the fundamentals of what does it mean, and you're just like, oh, let me put it in the calculator, you're not going to understand what it means. So I'm going to ask you, and if it's too hard to figure it out, then that's fine, and you can check it with the calculator. But I'm going to encourage you guys to try to at least do that in your head, and then you could check it after. So what number times itself is 81? Well, that should be easy, right? 9. But it could be 9, and it could be also negative 9, so I'm going to say plus or minus 9. Now, the next one has a negative outside. Now, really the negative should be here, but I couldn't really format it that way. Now, what does it mean if there's a negative outside? It means that we only want the negative square root. We don't care about the positive one. So I know that 11 times 11 is 121, so if I want the negative square root of 121, I'm just going to put negative 11. And the next one's the opposite. I just want the positive square root of 1. Well, what times itself is 1? 1, so it's just going to be positive 1. All right, how about 400? Well, I know 20 times 20 is 400, but negative 20 times negative 20 is also 400, so I'm going to drop that plus or minus there. What times itself is 10,000? Well, I know 100 times 100 is 10,000. I'm going to drop the plus minus. 196, I know that it's 14, so I'm going to say plus or minus 14. You can check these using a calculator if you need to, guys. All right, what about with the decimals? Well, this is going to be weird. Not weird, different. I shouldn't say that. All right, so look, what about the first one? Somebody else always says 0.05. And I say, let's see if we remember how to multiply decimals. So our procedure is we multiply normal, and we count the number of place values to the right of our decimals. Well, that doesn't seem like it works, does it? So we're going to say, well, how about 0.5? So if I do 5/10 times 5/10, I multiply normal. I count the number of digits. There's 2 of them. I move it back, and that's exactly what we wanted. I'm going to add my little plus minus. For the next one, I only want a negative root. So what's the negative root? Well, I know 121 has a square root of 11. And if I want 1 and 21/100ths, I'm going to put the decimal between the 2 ones. Now I just want the positive root. Now I know the square root of 4 is 2. And since there's 2 decimal places, I'll move it 1 decimal place. All right, now for the next one. This is kind of like, actually I shouldn't erase this. I should keep what I have here. So if I think about what I tried to do for the first one, where I used, 0.05 here, it's going to make sense for me to use 0.09, plus or minus. And again, check this in your calculator. Put 0.09 times 0.09, or I should really say the place value, 9/100ths times 9/100ths, and it's going to give you 81/10,000ths, which is what we were looking for. That's my plus minus. How about here? Well, the square root of the number 225 is 15. If I need to go 2 place values, I put the decimal there, and I'll add my plus minus. Now I know the square root of 1 is 1. Now if I was just to do this, 0.1 times 0.1 is going to give me, I should say 1/10 times 1/10 is going to give me 100th. I need to do that. And again, check it using your calculator. 100 times 100th is 1/10,000th. So let's take a look at some fractions. So let's take a look at 4/9. Well, what happens when we multiply fractions, right? If I multiply 3/5 by 2/7, I multiply the numerators, and I multiply my denominators. That's my procedure for multiplying fractions. So when I'm thinking about 4/9, I'm going to think about multiplying some same numerator and multiplying some same denominator. Well, really what we can do then is we can say if I need, and this is important, if I need to find the square root of a fraction, really what I'm doing is I'm taking the square root of the numerator divided by the square root of the denominator, right? And a lot of us can do this on our own. If I say, what's the square root of 4/9, someone's going to tell me 2/3, and I'm going to say, why? And they're going to say, well, because 2 times 2 is 4, and 3 times 3 is 9. And I'll say, absolutely, you're right. And I'll say, what did you do? And they'll just reiterate the same thing. I'll say, no, you really just found the square root of the numerator, and you found the square root of the denominator, okay? And this is important so that we can do it kind of by hand, because doing this using the calculator is going to give you decimals, right? Especially with this one, which is a repeating decimal. So let's look at the next one. I'm going to take the square root of my numerator, so the square root of 1 is 1. Square root of my denominator, square root of 9 is 3, and they want just the negative root, so I'll put a negative sign. Same thing here. I want the square root of 25, which is 5. I want the square root of 36, which is 6. I want the positive root. So I can put positive. I haven't been doing it. But you know that there's no sign that it's positive, right? If somebody says 2x and there's no sign, you know that means positive 2x. All right? Same thing all along here, guys, right? So square root of 81 is 9. Square root of 49 is 7, so plus or minus 9/7. Square root of 1 is 1. Square root of 100 is 10, so plus or minus 1/10. Square root of 400 is 20, and the square root of 16 is 4. Well, 20/4 is 5. Now, what could I have done? I could have simplified 400 divided by 16. And 400 divided by 16 is 25, and the square root of 25 is 5. Now, that's the only one we were able to simplify because there were common factors in the numerator and denominator. But really what we're doing with the fraction, and again, the calculator may or may not be super helpful for these, is we're going to take the square root of the numerator, we're going to take the square root of the denominator. All right, so this is a little bit harder. Now, obviously, if you put it in your calculator, it's not, but if we're doing this by hand, find the consecutive integers the square root is between. So if we have what's called a non-perfect square, so everything we've seen so far has been a perfect square, right? The square root of 100 is 10 because 10 times 10 is 100. What about the square root of 101? Well, it's going to be 10 point something. It's going to be a little bit bigger than 10, but it's certainly not going to be close to 11. So find the consecutive integers the square root is between. Well, I know the square root of 49 is 7. So the square root of 46 is going to be a little bit smaller than 7. So it's going to be between 6 and 7. And that's what we're looking for here. What's it between? And if you put this in the calculator, you're going to get 6 point something, I promise you. Now the next one's a little tricky because it's negative. So the square root of 9 is 3. What's the square root of 10? It's a little bit bigger than 3, right? It's about 3.1. Now this is negative though. So it's between negative 3 and negative 4. All right, because negative 3 squared is 9, negative 4 squared is 16, and 10 is between 9 and 16. How about the next one? Well, this one we have to do maybe a little bit more, right? The square root of 100 is 10. The square root of 121 is 11. Now, 115 is between 100 and 121, so this is going to be between 10 and 11. And again, put it in your calculator, you're going to get 10 point something. 28.3, we don't really care about the decimal. The square root of 28 versus the square root of 28.3 will almost be exactly the same. So I'm going to say, okay, well, I know the square root of 25 is 5. So the square root of 28 is going to be like 5 point something. Now, since it's negative, it's going to be between negative 5 and negative 6. Right? Negative 5 squared is 25. Negative 6 squared is 36. All right, what about the next one? Well, I know the square root of 900 is 30. I know that the square root of, I believe, 961 is 31. So that you could put in your calculator if you need to, right? That's going to be 961. And 999 is a little bit bigger. So this is going to be between 31 and 32. I'm okay with you putting this one into your calculator, right? It's going to give you 31 point something. And then let's take a look at this one, right? So I know that the square root of 625 is 25. Now 620 is just a little bit smaller than 625, so this is going to be really close to 25. It's going to be like 24.9 something. So I'm going to say this is between 24 and 25. Guys, this was kind of an extension, right? In other words, if you had trouble with this, that's okay. I'm not saying don't ask questions about it. I always encourage you guys to ask some questions about it. But this is just something that, you know, once we talk about square roots, there's a lot of little kind of extensions we can do, and this is one of them. So I wouldn't drive myself crazy if you're having trouble with this. All right, this we can skip. All right, let's talk a little bit about cube roots also. So cube roots really aren't something that you see until about the 10th grade. So again, it's not something we're going to get, you know, super stressed out about, but it's something that's worth looking at because it ties closely into square roots. So when we square something, we multiply by itself, right? So 5 squared is 5 times 5, whereas 5 cubed, right, the third power we call the cube, is 5 times 5 times 5. Now the reason we talk about these things, or we name them that, is 5 squared is how you'd find the area of a square with a side length of 5. And 5 cubed is how you'd find the volume of a cube with a side length of 5. So that's kind of where the terminology comes from. So the cube root of something is the number that you would have to cube or multiply by itself 3 times. So the cube root of 8 is 2 because 2 cubed is 2 times 2 times 2, which is 8. Now notice that we're not using negative 2. because negative 2 times negative 2 times negative 2 is negative 8. So we're not going to see that plus minus when we're looking at cube roots. What's the cube root of 125? Well, I kind of just answered that one right over here, right? 5 times 5 times 5 is 125. Therefore, the cube root of 125 is 5. What's the cube root of 64? Well, if I do 4 times 4 times 4, it gives me 64. So the cube root of 64 is 4. What about 1,000? Well, 10 times 10 times 10 is 1,000, so my cube root is 10. All right. So let's do, let me show you because it's not going to be until the next side. Right? What if I had the cube root of negative 125? That would be negative 5, right? Because negative 5 times negative 5 is 25 times another negative 5 is negative 125. We don't need to do this. What about the cube root of negative 64? Well, that would be negative 4, right? Because negative 4 times negative 4 is 16 times another negative 4 is negative 64. So again, those last couple examples, those are just kind of extensions, okay? The real heart of the lesson that I want to make sure you guys understand is, of course, this, right? What's the square root? A number multiplied by itself. And, you know, let's not fall into the trap of dividing by 2. I always have students that when I say, what's the square root of 400? They say 200. And I say, well, 200 times 200 is 40,000, not 400. So it's the number that when multiplied by itself gives you the number inside what we call the radical, right? This is a square root symbol. We also call it a radical, which we will simplify at some point down the road, probably closer to the end of the year. So I'm hoping that we understood this and this, right? And I'm hoping we understood everything. But that's the most important stuff as far as when we talk about Pythagorean theorem and solving equations with square roots. That's what I need you to know. All right, guys, today's homework is going to be a worksheet. All right, so the worksheet is attached. You're just going to complete that in your notebook, take a picture and upload. As always, guys, questions, comments, concerns, upload your work, leave me a comment on Google Classroom.